for the precursor. So one of the main component that is required for the Clipper circuit it's diode. And now today we discuss another roll number 78. Roll number 78. Stop your microphone. Roll number 8.
BB8ET. Cari kalau mereka mikir
So,
sir, I have one question from Clipper circuit.
Yeah.
Sir, in the previous you discussed about two level Clipper circuit,
Yes.
but when I am taking a different example from Clipper circuit. Suppose the diode 1 is connected. You can draw the circuit board. Suppose diode 1, the positive polarity of battery is connected with anode for the diode 1, and for diode 2, the polarity is connected with cathode for diode 1. So, how to examine between that negative positive polarity that I'm asking. For example, the negative polarity value is suppose minus 3 MP for diode 2, and for diode 1 taking 2 volt is connected. So I want to examine between minus 3 to 2, which diode is getting dominant here. I cannot find how to which diode is getting short circuited, diode is getting open circuited in this particular range.
Say this type of circuit is present.
Not like this, sir. Not like this. For the first diode, the cathode is connected to negative polarity. The N side, negative polarity, yes. And for the second diode, it is positive polarity. Yes.
Okay, so how to identify which diode is dominant and when it will be forward bias or reverse bias?
Yes.
So, say here we can apply some input signal and we need to calculate output that we have been getting here. Say these are the reference voltage VR1 and that is the reference voltage VR2. Because it will be considered as a reference because these are a DC, that means constant value. And that is a AC signal that is changes with respect to time. So now at first we draw the AC input signal. And obviously we consider the reference voltage that must be less than the peak value of the input signal.
Yes.
Consider the V max that will be greater than R1 and R2. So like this, here. Now, at first we draw here that is a VR1, that is a negative power supply because these are the reference terminal. So with respect to reference terminal, here we can apply minus VR1. So now we consider these are the minus VR1 reference level. These are the minus VR1 reference level. And with respect to this ground terminal, the potential at that point is VR2. So now we consider the VR2 level. Now we need to check which diode is on and which one is off. That the diode D1 and that is D2. Now, if a diode need to be conduct, it must be connected in forward bias. So when it is forward bias, if the positive terminal voltage just greater than negative terminal voltage. So if V positive that is greater than V negative, so now V negative is connected with minus VR1, minus VR1. So if the input signal that is greater than minus VR1, then obviously this diode will be on. And when it will be on, it can behave like a short circuit element. At the same time, here we see that the voltage is VR2. VR2 means when this terminal voltage is less than VR2, less than VR2, then the diode D2 is on. Less than VR2.
Yes.
So from here we can see that if the input signal is greater than minus VR1, then diode D1 is on. And when the input signal is greater less than VR2, then diode D2 is on. Okay. So now one thing, if any diode will be on or off, on the basis of this, the output voltage will be depends. Now, if we consider in this section, the input signal is less than VR2, and also greater than minus VR1. So obviously both the diode will be on, diode D1
Yes.
and D2 both are on, right?
Yes, sir.
Because in this section both the diode will be on. So both diode on, then diode can be when forward bias, it behaves like a short circuit element. So these two are act as a short circuit element.
Yes, sir, but in the previous class you told that both cannot be on, so that's why I am confused.
Now both diode is on. In that case, the diagram will be also different. In diagram, and this portion,
Yes.
so we have drawn here that is positive, this side will be negative. In that case, if you consider polarity will be changes, that side positive and this side will be negative, then the different condition arises. You see that if the input signal is greater than VR1, then the diode is on. Here less than VR2, then the diode is on. So in that case, less than VR2, only this section diode D2 on, only this section diode D1 on. But in between them, D1 and D2 both are off.
Yes.
For that reason, we get this type of waveform because D1 is on, so it voltage will be fixed at that particular value. In this section, both diode is off, so output is same as input. In that case, diode D2 is on, so the output voltage will be clipped at that value. In previous circuit will be different because here the biasing voltage will be changed. Now at
Yes.
that moment, at a time, is it possible? From this diagram, we see that if the input voltage is greater than minus VR1, diode D2 on, less than VR2, diode D1 on. That means in this section, both the diode will be on, D1 and D2. And if both the diode on, then we see that this voltage will be getting parallel. And we know that if the two voltage source connected, no meaning. In
Yes,
that
sir.
case, the output voltage will be clamped minimum value. Minimum value means here we see the voltage across these two terminals is minus VR2. So voltage across the output terminal, that is also minus VR. It cannot be moved above this value. So the output voltage is equals to minus VR2 when the diode D1 and D2 both are on. So in this region, both the diode will be on. So in this region, we get the output voltage is equals to minus where both the diode is on. If any one diode is off, then the output voltage is clipped in. Say here the input voltage is greater than VR2, then the diode is off. If it is off, then the output voltage is equals to VR2. Otherwise, its value will be fixed at minus VR1. Okay. We
Sir,
can.
is it possible practically?
Yes, possible
Because,
in practical.
because sir, here voltage in parallel means there is violation
that
of
means
KVL also.
voltage in parallel means we say that the Say you can apply the 3 volt and 5 volt parallel. Then what happens? 3 volt and 5 volt both are connected in parallel. Then in that case, the output voltage obviously equals 3 volt because its voltage will not be greater than this value. So if we apply the 5 volt, then it is still now it can be behaves like a 3 volt supply. So if we connected the two voltage source in parallel, then both the sources will provided the same value and the lower of these two. So here if we 3 and 5 volt these two are connected in parallel, then at the output terminal we get okay.
And sir, in this circuit, we will get V out as minus VR1, lower potential
In lower
in this circuit.
So in this section, V out equals to minus VR1 only this section where the input voltage is less than VR2. So where both the diode will be on, So up to that value, it will be equals to VR1 minus VR1. In this section, the input signal is greater than VR2. Greater than VR2 means diode D2 is on. D2 on means the output voltage equals to VR2.
VR2. Yes.
Output voltage equals to VR2. That means in this section, the output voltage equals to VR2. So the output voltage, if you draw the output voltage in this section minus VR1, then we get for this portion, it will be equals to minus VR2 plus VR2. Again, up from where the input voltage is less than VR2, then in that section, the output voltage must be equals to minus VR1. In that way, we get the waveform. Okay.
Okay, sir.
So we also do some example of Clipper circuit later. Now today, first we discuss about the clamper circuit. So what do you mean by clamper circuit? Clamper means that is basically called DC inserted circuit. DC inserted circuit. Clamper circuit means that is basically called the DC inserted circuit. That means it can be at some DC level in the input terminal. It can be at some DC level with the input AC signal. So clamper circuit, that is also called DC inserted circuit. This circuit basically at some DC level with the input AC signal. That means positive and negative peak of the signal can be placed at some desired level using the clamping circuit. Say we consider we are taking a AC signal that is 5 sin omega. Now, if we draw a 5 sin omega t, then the waveform is like that. With respect to omega t, if we draw here, the maximum amplitude is 5 and minimum amplitude is minus 5. Now, if we consider if we need to draw 5 sin omega t plus 2, then what happened? 5 sin omega t plus 2. That means minimum value of the input signal at that moment minus 5 plus 2. That means minus 3. And the maximum value of the input signal 5 plus 2. That means 7. And when the input signal value is 0, it can be shifted 0 plus 2. That means it will be starting from 2. So we can consider that is a 2. So it will be start 2 and then the waveform is same pattern. Waveform is a same pattern. So these are the two level. Now it will be moving in that way. Then it will be goes that way. So then it will be like this. So maximum value of the input signal will be goes to 7 and minimum value of the input signal that will be goes to -3. So that means we can add some DC level. In previous case, when we consider only 5 sin omega t input signal, then in that case, the DC level of the signal, how to calculate the DC level of the signal? We are basically calculate the area of the signal, average area of the signal. Now, in case of 5 sin omega t, how much portion positive cycle is present? Same amount of negative cycle is present. That means this point area is cancelled out with this negative area. That means the total area covered by signal that is equals to 0. So that means the DC value of the signal 5 sin omega t, that is 0. So DC value of the signal 5 sin omega t is 0. Now,
Sir,
if
please
we
repeat.
say that if we need to calculate the area of the signal, that is basically represent the DC value of the signal. Now, in case of 5 sin omega t, if we calculate the area covered by the signal, then we see that the positive area that will be covered by the signal that is equals to this negative area. That means the total area covered by this signal is 0. This area will be cancelled out by this area. So that means total area covered signal that is 0. That means DC value of the signal 5 sin omega t is 0. But if we consider 5 sin omega t plus 2, it can be shifted the DC level from 0 to 2. At that moment, the DC value of the signal is 2, not 0. At that moment, the DC of the signal is 2 and the maximum value of the input signal is 7. Minimum value of the input signal is -3. So the DC value of the signal 5 sin omega t plus 2 is 2. So we can add some DC level with the AC input signal. So any circuit that will be done these things, that circuit is basically called the clamper circuit. So clamper circuit is basically add some level with the AC signal. And the clamper circuit is also called the level shifter circuit because previous waveform the DC level is 0. But if we use the clamper circuit, if its DC level will be jumped from 0 to 2, you can say that the DC level will be shifted. So for that reason, the clamper circuit is also called the level shifter circuit. That means it can be shifted the DC level of the input signal. It can be shifted the DC level of the AC input signal. And if we need to build up a clamper circuit, then obviously here the main component is diode, and we can also use the resistor and capacitor to shift the waveform to a desired DC level and without changing the applied signal. So here we can apply the sine wave. After clamping, some DC level will be inserted, but still now the waveform pattern does not change. That pattern will be same with the input AC signal. So say we can apply the input AC signal is 5 sin omega t. After clamping circuit, we get 5 sin omega 2. So in that case, the waveform pattern does not changes. Only changes the DC level that will be shifted from 0 to 2. So for that reason, we can say that the clamper circuit is basically called the DC inserter circuit or level shifter circuit. So clamper circuit only adds some DC level with the AC input, the waveform of the applied signal. So no change in the waveform of the, like Clipper circuit. In Clipper circuit, we seen that the waveform pattern will be changes. So you can apply a square wave, we can get some distorted sine wave, we get a square wave also in the Clipper circuit, or we get the distorted square wave or distorted sine wave like this. But in case of clamper circuit, no form changes occur. The waveform pattern will be same. Only the clamper circuit adds some at this level with the input signal. Now, in case of Clipper, like Clipper circuit, the clamper circuit is also two types: positive clamper and negative clamper. Positive clamper circuit and negative clamper circuit. When the added DC level is positive, then this circuit is called positive clamper circuit. If added DC level is negative, then it is called negative clamper circuit. First, we draw a clamper circuit. Here we can apply some AC signal. Here basically use capacitor, and we can consider a diode is here connected, and after diode we can connect a resistor, and we take the output from here. So these are the AC input signal. These are the capacitor, diode D1, and the resistor. And from here we take the output voltage. So this is a one type of circuit, that is either positive clamper or negative clamper. So we can identify what type of clamper that is. Just drawing the output waveform. We already said that in the output waveform, if some DC level is added, that DC value will be positive, then it is called positive clamper. If DC value is negative, then it is called negative clamper circuit. Now, here we consider the VE. So initially, for the positive half cycle, we can easily say that the diode D1 is in forward bias condition. For the positive half cycle of the input signal, diode D1 is in forward bias condition for the positive half cycle. For the positive half cycle, diode D1 is in forward bias condition. In the positive half cycle, that is positive with respect to this end, because these are the reference terminal. So with respect to this end, that end is positive. This end positive means diode positive terminal is connected with the positive terminal of the supply. So diode is in forward bias condition. Now when it is in forward bias, then the capacitor start charging. Capacitors start charging through this path. Capacitors start charging through this path. Now, when the capacitor charge, we already know that the basic property of the capacitor, it can be hold the charges. Capacitor stores some charges in the as a electric energy. So when the capacitors stored the charges, that means voltage across the capacitor is continuously increases when the input signal increases. So when the input signal is at maximum value, so here the input signal is at maximum value, that is VL. Consider that voltage level is VL. So when the input signal is at minimum level, the capacitor is also charges at the maximum voltage, because this section will be behaves like a short circuit element. So total input voltage that will be developed across the capacitor. So if the input signal is minimum value, the capacitor is also charged in the voltage VA. That means voltage across the capacitor is now also the maximum, that is VA. We know that the capacitor is basically stored the charges. That means it does not instantly cannot be changes the voltage. So that means any voltage developed across the capacitor. So this voltage will be fixed or constant if the input signal decreases. So now, if the input signal is at maximum position, at that voltage developed across the capacitor, that is also VA, maximum voltage. Now after that, the input signal goes low, it will be less than VA. Capacitor, it can be hold the charges. That means the voltage across the capacitor will be still now is VA, that is a maximum voltage. So what happened? These are the input signal. That value will be decreases and it will be less than VA. And due to this voltage source, the capacitor is already charged in the maximum value VA. So now the voltage at that point, that is equals to VE plus VM. Just we can apply the negative, positive. These are the voltage will be done here. That is VE. That can be negative, positive. Here the capacitor will be charges. So sorry, V minus VM. That can be VE. Positive minus VM. So voltage at that point is V minus VM. Now that point voltage is V. V means that it changes with respect to time. So when the input signal is at maximum value, the capacitor will be stored the charges and it can be also charges up to the maximum voltage. So that means voltage developed across the capacitor is maximum, that is VM. Now when the input signal tends to increase and it will be less than VM, but still now capacitor hold the charges. That means it can be retained its previous voltage. That means VM. So now what is the voltage at that point? That is equals to negative, positive, positive, negative. That means V in minus VM. That is the voltage at that point. Now V in minus VM means at that point V in is less than VM. So what is the total voltage? V in minus VM. That means voltage at that point, say we can consider that is an anode terminal, so VA. We can consider that is a VA. That is also we can write V minus VM. So if the input signal is less than VM, the voltage at the point A, that is equals to V minus VM. Now, if the input signal less than VM, that difference is negative. V minus VM, V is less than VM, then the difference is negative. Negative means anode terminal of the diode that's connected with the negative potential, and the negative terminal of the diode is connected with the reference voltage of ground terminal. So that means the diode D1 is in the reverse bias condition. So it will be charges up to this value. Then it will be goes to, if the input signal decreases, it will be goes to, in that point the diode D1 is in the reverse bias condition. So now if diode D1 is in the reverse bias condition, so voltage at that point is equals to DI minus VM, that means input voltage minus VM. After that, for every input cycle, what is the output? That means the voltage at that point is VA. And for any cycle of the input signal, the diode D1 is always in reverse bias condition. Because we know that the maximum value of the input signal is Vm. So that point voltage anytime does not cover greater than Vm, not possible. So if it is not greater than Vm, then the diode D1 is always in reverse bias condition. So what is the output voltage? The output voltage that is equals to, we get V in minus Vm, because that voltage that will be also appeared here. These are the short circuit terminal. So the output voltage that is equals to, we can write V in minus Vm. Only for the first cycle, only for the first half cycle, the output voltage that is equals to 0, because the diode is on. But if we ignore the first half cycle, then after that any input signal, any cycle of the input signal, the output that is equals to V in minus Vm. Now clear kina? Amra first half cycle in case of that means capacitor will be charged up to this maximum value. That means up to these are the that is the value. So maximum value capacitor, these are the voltage across capacitor, and that is the input voltage. So maximum voltage across the capacitor is Vm. Now after that, capacitor basically hold the charges. It can be written the voltage across each. So that means voltage across the capacitor is fixed. After that, it will be constant. So if voltage across the capacitor is constant, then what is the output voltage? Only for the first half cycle, the diode D1 is on. D1 on means voltage across this terminal, because diode B is short circuit element. So if you draw the output voltage, then we get for the first half cycle that is 0. But after that, that voltage is equals to D in minus Vm. Now, if we draw the output waveform, then here we see that it will be decreases from Vm to 0. That means output that can be changed from 0 to minus Vm, 0 to minus Vm. So it can be starting from here and it will be changed from 0 to minus Vm. Then when the input signal is minus Vm, that is maximum value is minus 2 Vm. So these are the minus 2 Vm. These are the maximum or minimum value of the input signal is minus 2 Vm, and the maximum value of the output signal that is minus Vm, that is 0. So we get this type of waveform. So minimum value that is minus Vm, maximum value that is 0. So in that way we get the output waveform. We just connect properly. So these are the input signal. These are the input signal. And in case of for the first half cycle, 0. These are the output signal. Next half cycle, it will start from Vm. So Vm means Vm minus Vm 0. That means output is 0. Vm to 0. So when it will be 0, that means V in 0 minus Vm. That means output voltage is minus Vm. In that point, the output voltage is equals to minus Vm. Now, if we consider the input signal is here, that means minus Vm. So minus Vm, the output signal is equals to minus 2 Vm. So at that point, it is equals to minus 2 Vm. Then again, at that point, that is 0. So 0 minus Vm, again it will be goes to minus Vm. Then at that point, it is a Vm minus Vm, that is equals to 0. So Vm minus Vm is equals to 0. then again it will be down, goes down, so again up to minus Vm. In that way it will be changes. So that means we get this type of waveform. It is 0, so it is up to minus Vm. So we get this waveform. So here the minimum value of the signal is minus 2 Vm and maximum value of the signal is 0. If we just ignore this first cycle, then we see that this waveform pattern, that is also a sine wave, and that is given input signal, that is also sine wave. Only change is that here the signal varied from plus Vm to minus Vm to plus Vm, minus Vm to plus Vm, but here the signal varied from 0 to minus 2 Vm. So 0 to minus 2 Vm means the DC signal present in the middle of this, that means at the Vm level. So these are the DC signal. So DC signal that is equals to minus Vm. The DC signal of the output that is equals to minus Vm. So here the DC level that will be added with the input signal. So for that reason it is called negative Clampfer circuit. So these are the example of negative Clampfer circuit. Negative circuit. Now, any question?
So when the voltage across the capacitor is getting constant, repeat from there. After that, what happens?
If voltage across the capacitor goes to constant, so these are the fixed. So the capacitor obviously always need to store the charges. So it can be charged into the maximum value. Now after that it can be hold the charge. So that means it can be written its previous value, that means voltage, previous voltage. So it can be written its voltage Vm. Now if it can be written its maximum voltage, but the input signal is continuously decreases. After Vm it will be decreases with respect to time. It can maintain its voltage. So what happened? The voltage at that point, that is equals to, if we just write down the KVL for this negative positive, that means V in, positive negative, that means V in minus Vm, that is the voltage at that point. So now input signal is less than Vm, but voltage across the capacitor will be constant at Vm. Then what happened? V in is less than Vm. Voltage across the capacitor is equals to Vm. So V minus Vm, that term must be negative. So if it is negative, then the anode terminal of the diode is connected with the negative supply or negative voltage. The negative terminal of the diode is connected with ground. So what happened? This diode is in reverse bias condition. So if it is reverse bias means it is open. So if open means always open. So open means the voltage at that point is equals to V minus Vm. But one question comes in mind. Say the resistance is connected R. So capacitor start discharging through the resistor. Is it possible? Because if this charging path is open, then capacitor start discharging through the resistor, because it is not possible, say capacitor hold the total charge, capacitor retains the voltage at it. It is not possible, practical. Obviously, the capacitor can be also the leakage, current is flowing through the capacitor, and for that reason, some capacitor will be discharging through this path. Is it possible? But if you take in this type of circuit, obviously we take the resistance value that will be as much as maximum. So if the resistance value is maximum, then in this type of RC circuit, in circuit theory, we are already seen that in RC circuit, the time constant of the circuit is R into C. Time constant of the circuit is R into C. So if the C value is, if the resistance value is larger, then obviously the time constant is large. If time constant large, that means it can be discharges for of time. It can be discharges significantly very low. So we can ignore this discharging voltage. So if we ignore this, then we will get this type of waveform. So for that reason, in the clamper circuit, obviously connects resistance. That resistance must be very large. If we connect this resistance will be very large, then obviously no discharging path will be available. So if no discharging path of the available, then the voltage is same like this type of waveform. Okay. Any question? Now we need to convert this negative clamper circuit to positive clamper. What type of change is required in this circuit? So now we need to build up a positive clamper circuit. Here we can say that that is a negative clamper. So now we need to draw a positive clamper circuit. Then what change is required in this circuit? Positive clamper. Yeah.
ডায়োডটাকে উল্টে দিলে
Changing
ডায়োডটাকে উল্টে দিতে
Right. The direction of the diode will be changed. Okay. So first we can change the direction of the diode. We can just change the direction of the diode. So opposite direction, like this. Then what happens? Positive half cycle, the diode is in reverse condition, right? Positive half cycle, the diode is in reverse bias condition. So one thing must be remembered in this type of circuit, we start our discussion when the diode is on, in which cycle the diode is on. So it is not necessary we are start from the positive half cycle. We can also consider the waveform start from the negative half cycle. So in this type of circuit, at first we consider the cycle of the input signal where the diode is on. So if we consider the negative half cycle, then the diode is on. If negative half cycle diode is on means it can be behaves like a short circuit element. Now in that case, the capacitor will be charges if it is a negative half cycle. Negative half cycle means with respect to reference terminal, that terminal is negative. With respect to this reference terminal, that terminal is negative. Now at that moment, capacitor start charging and it will be charged up to the minimum value minus Vm max. That is basically the maximum amplitude. The shift is negative, but the maximum amplitude. So it can be charged and it will be charged up to the maximum amplitude, that is minus Vm. So now in that case, it will be charges in that way. We know that the current always flow from positive side to negative side of the supply. So current will be flowing in that way. That means capacitor will be charged here, that is positive. This side will be negative. For the negative half cycle of the input signal, and the maximum voltage developed across the capacitor is Vm. Maximum voltage developed across the capacitor is Vm. Now, same thing in the first half cycle, it will be charged in the maximum value, and from the next cycle, after first half cycle, the input signal just greater than minus Vm. Then the capacitor retain the charges. So what happened? The voltage at that point, that is equals to Vin plus. So we can consider the Vin. This side will be negative. That side will be positive because this Vin is minus V because negative half cycle minus V. But if we consider the input signal is V, that is Vm. So negative, positive, that is voltage at that point is Vin plus Vm. Vin plus Vm. So if we consider here, V data terminal is connected with ground. That terminal connected with ground. If this terminal voltage is VL, it will be more negative. That means what happened? The diode is in the reverse bias condition. So if it is reverse bias condition, the voltage at that point is V in plus VM. V in plus VM means our maximum minimum signal minus VM plus VM equals to 0, and where we get the maximum input signal, that is VM, so VM plus VM is equals to 2 VM. So the only change occur in the output signal. In the output signal, we see that for the first half cycle, the input signal is 0. For the first half cycle, the output signal is 0. Now, after that, it will be start from 0 to 2 VM. It will be start from 0 to 2 VM. It is a maximum at that point. And after that, it will be goes to 0 again. When it will be minus VM, it goes to 0. And then again, it will be changes up to VM. Up to VM. So these are the VM level. So you consider that is a VM level and that is a 2 VM level. So in that case, the signal will be shifted upward. The signal will be shifted upward. Here the minimum value of the signal is minus VM. We can just add the DC level plus VM and it will be shifted upward. So that is the example of positive clamper circuit. Example of positive clamper circuit.
স্যার গ্রাফটা আবার বুঝিয়ে দেবেন গ্রাফটা বলতে স্যার
গ্রাফটা
নেগেটিভ পজিশনটা শুরু হবে তো
আচ্ছা দেখো ফার্স্ট ইজ তখন তুমি ফার্স্ট আমি নেগেটিভ হাফ সাইকেল কনসিডার করছি নেগেটিভ হাফ সাইকেল ওকে একটু ভুল ড্র করেছি কারণ আমার ইনপুট সিগন্যালটা একটু চেঞ্জ করে দেওয়া উচিত ছিল তার কারণ we are starting from the negative half cycle sorry we are starting from the negative half cycle we are starting from the negative half cycle. That means when the input signal is minus VM, so when it will be changed from 0 to minus VM, 0 to minus VM, diode D1 is on. If it is on, then the voltage across the output terminal is 0. Now, when the input signal is less than minus VM, then what happens? When it will be less than minus VM, the voltage at that point is Vin plus VM. Now, when the input signal is less than VM, less than minus VM, so its value, these are the VM, its value is less than minus VM. So what happened? That value will be positive. That value will be positive when the input signal changes from minus VM towards the 0. So if the input signal is less than minus VM, that addition will be provide some positive signal. If it is positive signal, then the anode terminal of the diode is connected with some positive signal. Anode terminal is connected with ground, that means 0 potential. So what happened? This diode will be off. So if it is off, then the voltage across the output terminal that is equals to VA. VA means Vin plus VM. Now, if the value is minus VM, just put the values here. Minus VM plus VM that is equals to 0. So the output voltage is 0. When the input voltage is 0, at that point, the input voltage is 0, the output voltage is 0. If goes to VM, that means maximum value of the input signal. At that moment, VM plus VM, the output voltage equals to 2 VM. Again, input signal 0, the output signal is VM. Input signal 0, the output signal is VM. Input signal VM, the output signal is 2 VM. So that means the output signal always varied from 0 to 2 Vm. Always from 0 to 2 Vm. So we can see that here the minimum value minus Vm. It can be just added a plus Vm with this signal. Then it can be shifted from minus Vm to G. So it is called level shifter, as well as that is also positive Clampert circuit. So that is an example of positive Clampert circuit. Positive Clampert circuit. Okay. So Clampert circuit, we are basically at some DC level with the AC input signal. Here the DC value is G. In this signal, the DC value is equals to G. In this output signal, the DC value is equals to Vm. DC value is equals to Vm. Because this signal that can be also represented in that way, Vm plus Vm into sine omega t. That can be written in that Vm plus Vm into sine omega t. So this Vm, this DC signal added with the input signal. Because that signal will be represented as a Vm into sine omega t. So Vm into sine omega t, and this signal can be represented as Vm plus sine omega t. So Vm is the DC level, and that is the AC signal. So with this AC signal, DC signal is added. For that reason, it is called DC insert or Clampert circuit. Okay. Now, say in this circuit, if we connect some DC voltages here, say here we can connect some DC. What happened? What is the output waveform? If we VR input signal, then what happened?
Output voltage will shift to VR. Will start from VR.
It will start from
VR.
VR. Okay. That means it will be again shifted here.
Yes, like this.
Okay. So how it will be happen? Because same thing. So if the input signal is the here will be on, diode will be on if that point voltage is less than VR. If that point voltage is less than VR.
Yes.
Now in that case, the input signal value is less than VR, then it will be on. The diode will be on. So here, where the VR will be appeared? The VR will be appeared. First, we can check the input signal, negative half cycle of the input signal. So negative cycle of the input signal, it will be reduces still now. So it is minus Vm. Then we see that will be on minus Vm, because here it will be connected in plus Vm. Now, if it will be say in some voltage, this point here, then it will be on. So what is the ultimate voltage at that terminal? That terminal equals to V plus Vm plus the reference voltage. Reference voltage is also added with this signal, reference voltage. So the total output voltage, that is equal to V plus Vm plus Vr. So what happened? Due to Vm, it will be always shifted some level. With this, again the Vr level is added. So the signal is also shifted in some value here. The waveform is same, but it will be started from that point here. That point is equals to here. So these are the Vr. That point is equals to Vm plus Vr, and that point obviously equals to 2 Vm plus Vr. So here the input signal that can be varied from here to 2 Vm plus here. So these are basically called positive clamper circuit with with positive bias voltage, positive reference voltage or bias voltage. So these are called positive clamper circuit with positive bias voltage or reference voltage. Okay. Now, what is the application of this? So same way, we can also apply some negative reference voltages here. So if it will be negative reference voltage, it will be start from the negative voltage. So starting from minus here, because at that moment the input voltage output voltage is equals to Vin plus Vn minus Vn. So Vn plus Vn minus Vn means it will start from Vm minus Vr. It will start from minus Vr. Now one thing, this type of positive clamper or negative clamper voltage is possible. Now, what is the use of the clamper circuit? Where we can use this type of clamper circuit? And that is say in the positive half cycle of the input signal will be distorted. Say the noise will be added in some positive voltage. So in this section will be a noise added due to the high voltage. So at that case, we just shift the value, shift the signal in the lower level, then the noise is not added. So in case of, if we need to remove the distortion due to noise, then obviously we can shift the signal in the lower level. Or in sometimes it will be moved to the upper level. So it will remove the distortion. Next one is, it can be used as a voltage multiplier. Say we need to build a 24 volt say 24 volt that can be appeared across the load. But only the 12 volt supply is present in the lab. We need 24 volt. So in that case, using the clamper circuit, we can build up the voltage multiplier circuit also. So using this voltage multiplier circuit or clamper circuit, we can multiply the voltage by some constant factor. So that is either 2 or 3, it can be multiplied. So that means from 12 volt AC supply to we can get up 24 volt AC supply. So this type of voltage multiplier, we can use the clamper circuit. And obviously, these are the two main applications of this clamper. That is, the first one is if the noise is affected in the circuit, then we can just move the level of the signal in upward or downward by using the clamper circuit. Or the circuit is also used as a voltage multiplier circuit. So, as a voltage multiplier, we can use this type of circuit. Just okay, just 1 minute. I mean, voltage multiplier circuit draw করছি তো নিজেরাই explain করতে পারবে। তোমরা নিজেরাই explain করবে। The voltage multiplier circuit. So these are C1, that is C2, B1 and B2. So we say that it is a voltage multiplier circuit. Are you saying it is a positive voltage multiplier or negative voltage multiplier where you can apply the input signal? Then what type of output signal that we have been get from this circuit? Just check it. Okay. And next we have discussed about this matter. So this circuit is basically called a voltage multiplier circuit. তোমরা নিজেরা ট্রাই করে দেখো এটা কি ভ্যালু মাল্টিপ্লাই করবে +2 -2 and just check it. Okay. 62 63 now 71 7 83 84 86 88 to 89 89 98 to 100 98 to 100. Anyone present? 111, 118, 120, 121. Amit Ghosh, কত রোল নাম্বার?
Yes, sir. 121.
121.